In this video, we're going to talk about how things go in and out of the cell. We talked about the cell membrane and the proteins that are located on it. Now we're going to focus on how the cell interacts with the environment around it to move things in and out. So in and out of the cell we go. So how do things get in and out of the cell? Well, it depends on several factors, one being size, the second one being charge. The first process we're going to talk about, and you're also going to do this in lab if you haven't already, is the process of diffusion. And that's the movement of molecules or ions. Actually, let's take that word ions out of there. Let's cross that out. Okay, it's just the movement of small molecules through a selectively permeable membrane from high to low concentration. So what that means is small molecules are going to be able to go from high to low concentration in and out of the cell. Okay, in and out of the cell. So let me give you an example of diffusion. It's not really diffusion, but it's an example to show you how diffusion works. So let's say we were all going on a field trip, and let's say there's 25 people in the class. And so we get this bus that carries 23 people. Okay, so we got this bus with 23 people in it over here. So we got all these little people in this little bus. And so the bus is pretty full. Some of you are sitting on the floor. It's not really safe, but the university wouldn't give me enough money. But then one of you complains, calls in like you should, and said, hey, we got this bus, it's too crowded, we need another bus. So then another bus comes roaring up. Okay, here comes the second bus, and that bus is empty. Okay, that bus is empty. As long as I open the door and the door to this bus is open, you guys are going to move. Okay, you guys are going to move over to the other bus. Now if there's 25 of you in this bus, are all 25 of you going to move into this bus? The answer is no, you're not. About 13 or 14, 12 or 13 of you are going to move into this bus. So you diffused from a high concentration in this bus to a low concentration in this bus. Now one of the keys was that the door was open, so you could actually fit. Now if this is a regular school bus, and if you ever rode a school bus when you were a kid, you got the windows right by the seats. Now you roll down that window, or not really roll it down, but whatever you did to move that window down, could you fit through that window? Probably not. Not today. Maybe when you were 5, but not today. So if I kept closing the door over here and I said, fine, if you want to go, you have to go through the window, you couldn't diffuse to the other bus because you couldn't fit. Okay, you couldn't fit. So we have to have a high concentration and a low concentration, but you also have to be able to fit. You have to be able to fit. So this is where the small molecule part comes in. So for diffusion to occur, the molecules have to fit, and that's a selectively permeable aspect of the membrane. It can control because small molecules can diffuse and large ones cannot. There must be a concentration gradient, so there has to be a high concentration on one side of the membrane and a low concentration on the other in order for diffusion to occur. So high to low concentration. Diffusion will occur until equilibrium occurs. So what that means is if I had 25 people in this bus and then the next bus comes, you're going to diffuse, or you're going to move over until there's about 12 or 13 on each bus, and that's equilibrium. All 25 of you are not going to move to this bus, assuming I took a shower that morning. But assuming that's true, you're going to diffuse until you hit equilibrium. The advantage of diffusion and why we spend so much time on it is it saves your body a lot of energy. It's a passive process. The body does not have to produce energy in the form of ATP in order for this process to occur. As long as the molecule is small, as long as there's a concentration gradient, diffusion will occur. And normally this is a good thing. It allows water to move where it needs to go in your body. It's the reason oxygen can get to from your lungs into your bloodstream. It's the reason carbon dioxide can get from your bloodstream into your lungs, and then you can get rid of it. So the body likes diffusion because it's efficient and it's passive. It doesn't take energy. Now osmosis. Osmosis is just the technical word for the diffusion of water. The principles are going to be the same. If you've got our 2 buses, but now you think of the people as water, right? Water, these people are going to diffuse from a high concentration of water to a low concentration of water. So it's just about water, but it's so important that it gets its own name, and its own name is osmosis. So osmosis is the diffusion of water. Water will diffuse from an area of high concentration of water to a low concentration of water. And the reason I'm emphasizing the water aspect, you'll see why in a little bit. Sometimes the terminology that is used can be a little bit confusing. Alright, so here's our terminology. Solute and solvent. Okay. Solvent is what solute is dissolved in. Solute is the stuff that is in the water. Okay. This is the part that can't go through the membrane, okay, that can't go through the membrane. So the salts, the glucose, the proteins, they are too large and they will not move back and forth from high to low because they can't fit through that selectively permeable membrane. The solvent is what the stuff is dissolved in, or what the solute's dissolved in. So if I had a glass of water and I put some salt in it, the solvent would be the water. The solute, the stuff in the water, would be the salt. Now what you have to do to determine where water is going to move is you have to look at either side of the membrane, and you have to figure out which side of the membrane has more stuff. Now the more stuff the solvent has, or the fluid has, the less water it's going to have. Hypotonic is you have less stuff, which means you have more water. Now these terms, hyper means more, hypertonicity, more stuff, or higher solute. But if you have more stuff, then you have less water. Hypo means less, so here's less stuff, but if you have less stuff, then you have more water. So the terminology, you're identifying the sides of the membrane by the amount of stuff they have. But to determine which way water is going to move, you're also going to have to look at how much water it has. So that's why I emphasized up here that osmosis occurs from a high concentration of water to a low concentration of water. Now I'm going to show you an example here. You're going to give me some answers, and then we're going to spend some time with this on class. It's that important. And you're also going to do it in lab. You're going to do an egg experiment, or you may have done it already, and so that'll give you some practice. Alright, so here's our cell, or our intracellular fluid within the cell. Here's our selectively permeable membrane. Okay. This stuff here, these blue circles, dark blue circles, that is the solute. That's the stuff, and it can't fit. The rest of this area, this light blue, are all water molecules. Okay, are all water molecules. So the first thing you have to do when you're trying to do an osmosis problem is you have to figure out which side of the membrane is hypotonic and which side of the membrane is hyper. So remember, hypertonic, more stuff. Hypotonic, less stuff. So I'm going to give you a little bit of time, or you want to stop the video now, and I want you to figure out which side of the membrane is hypertonic and which side of the membrane's hypo. That is step one. So go ahead, if you need to, stop the video and see if you can come up with an answer. Okay, the correct answer is the inside of the membrane here is hypertonic because it has more stuff. Here's the stuff. If you have more stuff, then you have less water. So, hypotonic, hypertonic. So here's the hypotonic because there's less stuff, which means there's more water. Okay, there's more water. Now there's another term that I'll introduce you to now, and it's called isotonic. Okay. If you don't know what the term iso means, it means same. Okay, it means same. So isotonic would mean that each side of the membrane has the same amount of stuff and the same amount of water. And we'll come back to that in the next slide. Okay, we'll come back to that in the next slide. But in this case, you have a hypertonic and a hypotonic. So we have one side of the membrane that has more water than the other side. So I want you to see that's the next question I'm going to ask you. Okay, so which way will the water move, and will the cell get bigger or smaller? Okay, which way will the water move, and will the cell get bigger or smaller? So if we took this cell and put it in this environment, what's going to happen? Again, stop the video and think about the two questions. Which way will water move, and will the cell get bigger or smaller? And then start the video back up once you come up with an answer. Okay, now just a reminder, this is the hypo side, hypotonic, and this is the hypertonic. Okay. So this side has less stuff, but it has more what? It has more water. The hypotonic side has more water. This side, the hyper side, has less water. So looking at the rules of diffusion and osmosis, water is going to go from a high concentration of water to a low. So what's going to happen is water is going to go into the cell. Now if water goes into the cell, then what's going to happen to the size of the cell? Okay. So there's your arrow showing the water going in. What's going to happen to the size of that cell? the cell's going to get bigger. Okay, the cell's going to get bigger. Now let's go back to the isotonic idea. If you have something that's isotonic, here's your cell. Okay, here's your cell and here's your fluid. If it's isotonic, so you got concentration here, same amount here, where's water going to move? Where's water going to move? Water's not going to move because you have the same amount of water on the outside as you do on the inside, so water's not going to move. So this would be the situation in an isotonic situation. Okay. So what you have to get comfortable with is those definitions of hyper and hypo, and again we'll spend a little bit of time with this in class. Give you a practical example. Isotonic, when you get an IV, most of the time the IV you're going to get is going to be isotonic to the cells of your body. What we normally want to do is we want to get fluid into your body, but we don't want to make the cells grow or get smaller. So most IVs are 0.9% sodium chloride. That's a 0.9% sodium chloride. That is isotonic to the cells of your body. So we put fluid into your body by giving you this type of IV, but we don't change the size of the cells. Occasionally, and we'll get into this, you do give a person a slightly hyper or slightly hypotonic solution in order to deal with their health issue. All right, how else do we move things that are too big? Okay, how do we move things that are too big to go through the membrane or are charged? Okay, so larger molecules cannot diffuse through the cell membrane. The other thing that can't diffuse is ions. Okay, ions can't diffuse because they're charged. They'll get repelled by the cell membrane, and I mentioned this in the last video. So facilitated diffusion, the principles of diffusion are the same. We're going to go from high to low, but we need something to help us, to facilitate. That's where the word facilitated comes from. We need something to help with this process, and what's going to help with this process are channel proteins, and we mentioned these channel proteins when we talked about proteins that exist on the cell membrane. So facilitated diffusion, you're going to need channel proteins. It's still going to go high to low, and it's still going to be relatively passive. So if you watch over here, okay, watch over here. Here you have a high concentration of the blue. Here you have a low concentration. So what's going to happen is this. First of all, these are too big, or they're charged, so they can't fit through the cell membrane. So what's going to happen? As long as this channel protein is open, they're going to diffuse from high to low. So that's the process of facilitated diffusion. Again, with larger molecules or ions that can't fit through or won't go through the cell membrane. The last one, actually not the last one, the next one we're going to look at is called active transport. Active transport. Sometimes molecules have to go against the concentration gradient. They have to go from low to high, okay, from low to high. Now, the example I always use, we're going to use channel proteins like we did in the last one. The example I always use is back in the 60s and 70s when the VW Beetle was real popular. Now, I didn't do this, I was too young. But what they did on college campuses was they would see how many people they could fit into a VW Beetle. And the record ranges anywhere from 17 to 24 people depending on which model of the VW Beetle you look at. But just imagine that you're person 15 getting into that VW Beetle. Okay, so they've gotten 14 people in there. They're going to try and push you in there. Okay. Are you just going to be able to walk into that VW Beetle and sit down like you would in a normal car? No, it's going to take energy to get you in there. So someone's going to have to take your neck and turn your neck and move your arm and then push you into the VW Beetle. That is an example of something that's similar to active transport. You're going from a low concentration outside the car to a high concentration inside the car, and in order to do that you're going to need to use energy in the form of ATP. Okay, in the form of ATP. So again, if you look over here, okay, we're going to need energy. We're going to need energy. So again, I gave you the example of the VW Beetle, and here it comes. Okay. Now watch what's going to happen. Here we have a high concentration here on this side of the membrane. Here we have a low concentration. So what's going to happen? In order to get things to move from here into or out of the cell, we're going to have to use energy to do that. We're pushing that molecule against the gradient. So that is active transport. The last two, these are actually the last two, are endocytosis and exocytosis. This is what the cell's going to use when it has to move large molecules out of the cell or bring large molecules into the cell. Now it's pretty easy to remember. Exo means exit. So exocytosis is going to be the way a cell is going to release large molecules. Endocytosis is the way it's going to bring large molecules in. So here what you see, this molecule right here, whatever this is, that's got to be brought into the cell, it can't fit through the membrane because it's too big. It can't fit through a channel protein because it's too big. So literally what the cell is going to do, it's going to engulf it like a Pac-Man, surround it with its cell membrane, and bring it into the cell. And that is endocytosis. Okay, that is endocytosis. One example of this in the body is called phagocytosis. And it's one thing that your white blood cells do. Remember we talked about if a white blood cell sees a bacteria that's foreign, I told you it was going to kill it. One of the things it's going to do, it's literally going to engulf that bacteria and inactivate it. And then we have exocytosis, where, for example, your pancreas cells make insulin. Well, insulin's too big to diffuse. It's too big to go through a channel protein. So what the cell will do is engulf the insulin and then release it into the bloodstream. Okay, release it into the bloodstream. Well, then we'll travel through the bloodstream like we talked about before, bind to a receptor protein, and open a door so glucose can get in. So these are the two ways that cells can get things in and out that are very large. So again, just go back and review the ways that a cell can move things in and out. We will focus on diffusion in class so you get a good grasp of that concept.